Okay, hi. Let's go through the paper that we went through today in class. So let's finish up going through this. Anytime you have any question, please ask me. You can text me or whatever method you find. Okay, question 18. What's happening here? Okay, I can see that they are talking about it has nitric acid and silver nitrate. Perhaps silver nitrate you're not too familiar, but nitric acid, what do we know about nitric acid? It's clearly a strong acid. In fact, if you recall, what are the three strong acids you learned? Nitric acid, hydrochloric acid, and H2SO4 sulfuric acid. So by default, these are the three strong acids you learn. Every acid that you come across should be weak, unless they say unless otherwise. So these are the three strong. And strong acid means what? It should have a pH of usually 1 to 2, at most 3, which means the answer can only be A, isn't it? That's all. Yep. Okay, next one. Which of the following salts cannot be prepared by? Very simple. So let's take a look. So you have an acid metal reaction. So acid metal reaction. Do you recall acid metal reaction? This is actually your displacement, right? And what's displacement? The more reactive element, so by itself, kick out and replace the less reactive element in the ion form. So remember your series. Please stop calling me a zebra. I like. Yep. So in this case, it's an acid. So A can be prepared. Why? Why? Let's take a look. CaNO3 2. Why is it so? Because your calcium is group 2. So 2 valence electron. That's why you end up have a Ca2 plus. Nitrate, if you recall, you need to memorize. So Ca2 plus, NO3 minus, you cross method, you get this. So this is made from what acid contains nitrate? Nitric acid. And you have a metal which is calcium. You notice element. And if you compare, let's take a look. Let's color code it. Calcium, this here. Hydrogen is here. It is higher up, right? So it can kick it out. So it can happen. Calcium nitrate plus the H2 that's kicked out per se. So A is fine. A can be prepared. Question asked for cannot be prepared. Iron 2 chloride. Iron is here. And we can see iron is more reactive or higher than your H. So it can kick the H out and replace it. Fine. D, zinc. Zinc is here. We can also see zinc is higher than H. So it happens. So answer is C. Because why? Your silver is here. Your silver is below hydrogen. How does silver kick it out? It doesn't work that way. So the answer is C. Question 20. Wow, what's happening here? So okay, don't worry. I know this has the name suggests it's a qualitative analysis. We never learn qualitative analysis, but with our current knowledge of what we have learned so far, your acid, bases, and salt, and whatsoever, you actually can solve the question. So let's not panic and take a look, alright? So you have substance T, you add into a salt solution. Okay. Then, okay lah, let's just skip this question. Let's try to make your life a bit simpler. Let's not apply to this situation. Okay, same thing. 21 is out because why it's considered a QA, qualitative analysis. We have not learned that yet. Question 22. We can do 22. Why? This, okay, let's take a look. It's a periodic table question lah. So many things happening here. So let's try and figure out what's happening. So option 1 is talking about reactivity. Reactivity. So let's talk about reactivity then. So first and foremost, what's reactivity? They love to ask you reactivity of group 1 and group 17. Group 1 and group 17 element. They like to ask that. Then how to do? Very simple. So I would usually just write down 2 equations to see a pattern. Meaning, for example, Na, when it reacts, the sodium atom will become the ion. I mean, what else can you be, right? You are the element, which is no charge. You become ion, you got charge. And I balance the equation. Oh, okay. Then the one right under it, potassium, I'll get K plus and electron. So just from these 2 equations, I can see a pattern there. So the pattern is mass lose 1 electron there. Oh, we can see that, right? So I'm going to define reactivity of group 1 metal is basically how easily it loses the valence electron. Or in this case, the 1 electron. So once you have a topic sentence in this case, you can start to argue. So what happened down the group? Down group 1, there is more electron shell. Remember the example? Me standing in the front and each table is like 1 extra shell. So when there's an extra electron shell and an extra table, I can't really reach the outermost, the furthest student as well. Sound familiar? So the next thing you tell them is, oh, with the extra shell, the attraction between nucleus and valence electron is weaker as a result. It's further away. Oh, okay. So that means down the group, the attraction is weaker. So you look at the original so-called topic sentence. So if the attraction is lower, means it becomes easier to lose the valence electron, right? And what's reactivity? Lose valence electron. If it is easier to lose, therefore reactivity will increase down the group, because easier to lose and losing electron is reacting. So based on this alone, option A, is it less reactive, has it increased? No, it's not less reactive, it's wrong, it's more reactive, because down the group, more proton, right? More electron, more everything, but it is actually more reactive, as we have explained here. They form chloride of similar formula. Alright, let's take a look then. So I have Na plus and Cl minus. Cross method, I get NaCl. Oh, 1:1. 1:1, sure. What about K plus and Cl minus? Cross method, KCl. They are both similar. 1:1. Which means B is a true. C, they form oxide that can be easily reduced. What's happening? Okay, don't panic. So that means carbon plus oxide, let's say Na2O. Is there a reaction? Do you remember the reaction? No, don't worry. Can you see here? There is an element. If there is an element, let's take a look. Carbon versus sodium. Carbon is here. Sodium is here. Can carbon kick out sodium and takes its place? Cannot, right? Because carbon is below sodium. So in this case, there is no such reaction. No reaction. Because carbon is lower than sodium, which means C don't even it don't even react. What, reduce and everything? It don't react. So this explains option C. Why is it wrong? Let's look at the option D. The proton number of the element is 1 greater than the one above it. I mean, if you look at the periodic table, sodium proton number is 11. Right under it, you have K is 19. 11 to 19 is a difference of 8 lah. What is this 1 greater? Where the 1 come from? So Mr. 1 say 1 is wrong. So answer is B. Alright. Okay, 23. Property of potassium iodide. Cool. I have no clue what this is, right? Okay, never mind. Don't panic. What we know is potassium, group 1, means 1 valence electron. Okay, let me zoom in further. That means there's 1 valence electron. 1 valence electron means you will lose the 1, you get K+. It's a recap on how to figure out the ionic compound formula. And I can guarantee you, this is one of the most common mistakes that students have because they never really balance. Everything also 1:1. So you get NaO, MgO, AlO, OOOOO, OMG. Cannot. Okay, next one, you have iodide. I is iodine Iodine is group 17. 17 means 17 valence electron, is it? No, it's 7 valence. So if you have 7, is it easier to lose the 7 or gain the 1? 1 is easier. So you gain 1 electron, you get I minus. So you do cross method, you end up, oh, this is Ki. Cool. So, conduct electricity. When you think of conduct electricity, I think of bonding, isn't it? So I see a metal. I see a non-metal. So what bonding do you think this is likely to be? Ionic, right? So if you recall, ionic, aqueous and molten can conduct electricity. Why? What do they have? Because they have mobile ions. Your that giant ionic lattice gone. So actually A is wrong because it conducts. Right? Okay, let's look at option B. Okay, brown solution with sulfur dioxide. Okay, you cannot do option B because we don't learn it. Option C. Option C is interesting. Why? Chlorine. So you have Cl2 plus Ki. You recognize, right? This is an element. And I said before, usually if there is an element involved, it's decent chance that it could be a displacement. So just now, I have gone through right before this that group 1 down the group more reactive. Now you talk about group 17. From metal to non-metal, of course it should be the opposite, right? So down the group it is less reactive. Okay. Then you look at a periodic table, you will get Cl, Br, I. So this is actually more reactive. So Cl is more reactive than Ki. So can react, So kena kick out. I is kicked out. And you get KCl. You go balance it, you get this. Okay. So option C say it is decolorized. So it's about color, right? Okay, fine. So initially you have this. This is not transition metal, which means this is very likely to be a colorless solution at the start. When you react, you form another KCl, which is also no transition metal, also colorless solution, which means I'm not gonna care lah, because they have similar. But what about bromine? If you recall, when you are young, or I mean you are still young, if you fall down, your parents or whoever that is may take some yellowish, brownish liquid to put on your wound to kill germs, kill bacteria. That is iodine. So iodine is typically a brown solution. Oh, so in this case, right, what you observe, meaning what would you see? You will say that, oh, the colorless solution, which is what you have at the start, turns brown. So that's what you actually see. But let's look at option C. It says decolorize. What is decolorize? I see this word, I see the word de and color. So decolor means I go from something that has color to something that has no color. I lose my color. But looking at the answer here, colorless to brown, it is the opposite. So it is not decolorize. C is wrong, A is wrong. Answer is probably D. But let's continue and prove to ourselves that it's correct. Aqueous bromine, which is Br2 plus Ki. Again, Br2 is higher than I. So Br is the more reactive. More reactive means kick out lah. You get I that is kicked out. Then KBr, balance it. Oh, it's correct, right? You do form iodine. Because why? Bromine is more reactive than iodine. Hence answer is D. Okay, next, transition metal. Okay, so if you recall, transition metal, what do you have to know? You don't have to know much, but there are like about 3-4 characteristics of transition metals. So first is it will form colored compounds. That is one of the answer. Next one, A is wrong. Why? A, conduct electricity, conduct heat. This is actually a property of metal. Any metal can conduct one. So it is not a TM. It is not unique to transition metal. It's just metal. It proves that it is a metal. Hence, A is not the answer. D. This is what they say, metal plus acid give you H2. All it is proving here, right, is that chromium is more reactive than the H. That's why the chromium can kick out the H. But does it tell you that it's a transition metal? No. Option D merely tell me the reactivity, the difference in reactivity. Option C, it burn. Okay lor. What does it tell you? It doesn't tell you anything. It just say that it can burn or it can form this lor. Then no meaning. So it is not suggesting anything. So answer B is the answer. If you recall this, right? So your series, same thing. Please stop calling me a cute zombie. Right? So, steam? What's happening? So you see what happened? Mg plus H2OG. Hey, what do I see here? Element. If I see there's an element, what do I think of? The good chance is a displacement. So let's compare Mg and H. Can Mg kick the H out? Can. Mg more reactive, right? So H is kicked out, H2O, and now you have Mg, which is 2 plus, O2 minus, MgO. Oh, so Mg can react with steam. So actually, you think of it this way, what kind of metals can react with steam? Means the metal must be more reactive than H lah. So technically speaking, all these metals can react with steam. Because they are more reactive, they can kick it out. Right? Okay. Then cold water. So if you recall, cold water is why cold? Contrast that it's really low temperature water, a very very mild conditions. So this is actually reserved for the top 3 metals because they are so reactive that just merely cold water, no heat, cold water is a dangerous reaction and everything. So it says react with steam and not cold water. So copper is out. It doesn't even react with steam. Copper is below H, no go. Calcium react with both. So this is both. This is none. Magnesium and iron. So both will react with steam, but not with cold water. So you see, these 2 answers technically both correct, but if I have to choose, I will choose iron. Because iron is less reactive. Magnesium is like very near calcium, right? So it's like can react a little bit. So it's like a better answer thing. Okay, let's take a look at question 26. Where's question 26? Okay, question 20. Question 26, what's happening? See, potassium with cold water. So this is a very common, that the 3 metals, your 3 metals, let me highlight for you. These 3 metals here lah. So these 3 special metals, metal plus water, which is liquid, give me alkali, which is metal hydroxide, alkali, and H2. So hydrogen gas, is it alkaline? No. The only alkaline gas you learn in your syllabus is ammonia, and there's no ammonia here. So alkaline is out. Acidic? No. H2 is actually neutral. Next. Well, the answer is that there, right? It formed an alkali. Alkali means alkaline. So answer is B, lor. Yep. Okay, I'm not very sure if you have 27 or 28, but I'm going to talk about 27, 28. Okay, if you recall, in the in the reactivity topic, I mentioned that there are 7 reactions. Flashback, remember? 6 of them is displacement. So I also convinced you before, right, that if you remember displacement, IC element, just kick out lor, and whatever that's left will be the product. So it works, but one of them is not displacement. So this is the case. So I'm gonna write here lah. Alright. So let's go through some content. So this is the reaction, is metal carbonate. You heat it, you will get metal oxide plus CO2. So we call this thermal decomposition. Okay, don't be scared. Thermal means heat, isn't it? So it's using heat to break down. So it's using heat to break down. Thermal decomposition. So you need to know this equation and write equations for them. Alright. Second thing, you need to know the trend. So the more reactive the metal, the harder it is for the metal carbonate, be careful, I said metal, then the metal carbonate to decompose. Maybe I give you an analogy lah. An analogy. So okay, so I write equations for you. Okay, 2 example. I choose something that is normal. Something is very reactive. For example, Na2CO3. I heat, I get Na2O plus CO2 versus something that's less reactive, copper carbonate. I get copper oxide plus CO2. What's the difference? So the analogy is this. So the more reactive metal is like a better player, a better basketball player. So you see, what's happening here? You are essentially breaking it down, right? So imagine with me, this carbonate thingy that is taken away refers to ball. Alamak, oops. Refers to a ball. Ball. So it's like, the more reactive the metal, the more pro the basketball player is. Maybe a national player. You want to take the basketball off a national player, I think it's very difficult. So I think maybe this analogy helps you. So the more reactive the metal, the so-called more pro the player, it is harder to remove something from it. It's harder to remove, for it to break down. To what extent? To the extent of the top two metal, sodium carbonate and potassium carbonate will never ever decompose. It is not even possible. So this does not take place. So it's like, imagine the top two metal carbonate, or the top, they are analogy wise, they are like the LeBron James, who else? Michael Jackson. No. Michael Jordan. Like, wow, not even like good player. It's like got like whatever you call that lah. So it's impossible for them to lose the ball. It's impossible for them to break down at all. We have 30 players surrounding him also, cannot. It's the idea lah. It's the idea. Alright? So based on this logic, sodium carbonate never decompose, right? So actually, answer is just B, right? If you look at the series, sodium, please. Okay, let me write for you. Please, you need to be familiar with the series. Please stop calling me a cute zombie eye. Sodium is here. The next one, iron. Iron is here. It's getting less reactive, so it's a bit easier to decompose for the carbonate. Next one, lead. Lead. Pb is lead. Then after that, silver. Okay. So answer is B. Alright. Okay, question 28. I don't think it's printed for you, but we can still look at it because it is a very decent reactivity question. So let's take a look. So what happened? So first one. Let me find space. Yes, here. So I add nickel to the metal solution, W solution. So I mean, for convenience sake, for argument's sake, let's talk about a chloride lah. Let's say. So Ni plus WCl2. Ni is an element, But do you know whether it's more reactive? I don't know. We don't remember nickel. But can we see? Initially, nickel is 6 grams. After that, it becomes 5 grams. So this shows that some nickel reacted. That's why your nickel become less. So this tells me that nickel is more reactive than W. That's why nickel element can kick out W. Make sense? What about X? I add nickel. Did the nickel change at all? no nickel used up. This tell me that X is more reactive than nickel. So nickel can't do anything. It can't displace it. Next one. Y. 6 to 4.5. It shows that some nickel reacted. But isn't it suspicious? W 1 gram used up. Y 1.5 gram used up. So what does it tell you about reactivity? So it tells you that nickel is more reactive than Y and is more reactive than W. Oh, oops, I write wrongly. Y is less reactive. Why? The greater okay, you see the lower the less reactive the metal is, the more likely it will get displaced. So that's why you realize in this case the difference in nickel tell you the difference in reactivity. And last one, Z, start with 6 gram, 0. So all nickel react. That means this Z metal very lousy, very not react. Okay, it's very low in reactivity. So Z is the least reactive, so it can easily get displaced. Followed by Y, followed by W, followed by nickel, and followed by X. Nickel cannot kick out X. So Z could be nickel. Wrong lah. How can nickel kick out nickel from nickel solution, right? No make sense. B, metal Y can kick out Z solution. Metal Y can kick out Z solution. Okay, makes sense, because Y is more reactive. Y plus, let's say, ZCl2, Y can kick it out. So you get YCl2 plus Z. So B is the answer. Then C is wrong, as you can see. W is not higher. It is not higher. Then Y is, so again, wrong. Alright? Okay, let's go to the structured question now. Oops. Where is it? Structured question. Okay, let's go through each question. Hey, I believe question 1 is not inside. Don't worry. Because the things here, we don't... Okay, can. So I know this question 1 is not here. But let me give you a bonus question then. So based on what we learned so far, we can do B. So you can try to do B. How do you do B then? You recall what thing can react with acid and alkali a word that starts with A come to your mind, right? Your amphoteric oxide. Amphoteric means what? It can react with both acid and alkali. And do you remember what are the 3 examples of amphoteric? They are lazy, but no why so you don't ask why, right? Do you recall? So, do you have a lead oxide, aluminium oxide, or zinc oxide in this question? You have aluminium oxide. Alright. Next. Question 2 is inside, I believe, if I do recall saying this. Okay, so let's take a look here. You look at this movement of the gases. So actually it should give you an indication that this is a diffusion question. So which one will change color first? The paper 2. Why? So first and foremost, I will tell them NH3 has a lower MR of 17 compared to what? Compared to HCl, which is 36.5. Okay, I need you to take note of something. Wrong, immediately wrong. I don't want to say this, your hydrochloric acid diffuse. Because why? HCl is AQ. It's not, okay, hydrochloric acid is an AQ. It's a solution. The solution don't really diffuse so quickly. What we are looking out for is your HClG, which is called hydrogen. Let me zoom in for you. Hydrogen chloride gas. But then again, we can beat the system by not even spelling it. Why don't you just write HCl? You won't go wrong, right? So in this case, first mark, I will tell you that it's lower MR of this. So what? So your ammonia will diffuse faster lah. Faster to where? Faster to the left than your HCl diffuse to the right lah. So there is the 2 marks. It's pretty standard lah, diffusion. Do take note, they can test you on definition of diffusion, although not that frequent, but it could be a 1 mark question. Okay, next, universal indicator paper 1. So what happened is ammonia goes to paper 1, HCl goes to paper 2. So ammonia, what do you know about ammonia? We recall that ammonia is a weak alkali. So weak alkali should have a pH of, answer key shows a range lah. So if you write 9 or 10 or 11, they are all perfectly fine. I can accept that. Do you remember the color of universal indicator? You might not, so let's do a very quick revision. Universal indicator, pH 7 right in the middle, this is green. 8 to 12 is blue. Then the very alkali is purple. 3 to 6 is yellow. Then 1 to 2 is red, very acidic. So in this case, this is actually a blue, and this is a red. I mean, the pH of 1 or 2 lah, very likely, because it is your HCl. Remember at the very start of the video, HCl is your strong acid, so it should have a very low pH. Yep. Okay, give me a moment. Okay, question 3. Give me a moment. Let me drink a bit of water. Okay. Okay, question 3. Honestly, if I were you, I see the question, I'd be scared. 5 marks. So let's not panic. Let's slow down and do step by step, alright? So actually this question, there's a few methods. Some of you may have looked at the answer key and you can see a few methods. So I'm only going to show you one of the method. So, I mean, you can in exam context, some questions have a few answers that are accepted. And don't worry, we will not penalize you for this kind of situation. Because why? Exam is to test for your understanding. Alright, okay, let's take a look. So I have a solid mixture. So they are all solid at the start. So what is happening here? You will separate them. So what I'm looking out for is the word pure. Fine. So there's a lot of things here. So you can target any of them first. But for example, let's say I do, right? I will first say that I will heat the solid mixture so that my naphthalene sublimes. Sublime means what? Sublime means solid to gas. If you don't recall, let me shift it down. Okay, sublime is, there are a few examples. Let me quickly recap on a few examples. Your CO2, which is your dry ice, if you recall, they sublime. Iodine, sublime. Yeah, ammonium chloride, which is a bit weird. So ammonium chloride will become two gases, NH3G and HClG. So these are the few examples. Yes, naphthalene also sublime, but I usually don't really mention it because it's such a difficult to spell thing. And you don't need to know the formula for naphthalene even after we learn organic chem. Even you go JC and you learn organic chem, we also don't make you memorize the formula of naphthalene. Yeah. Okay. Coming back, so I heat so that it's sublime. Sublime means it become gas, but you are not getting the sample yet. And collect naphthalene. How? You will using a cool, clean surface. So if you look at textbook, right, they usually use a inverted filter funnel, something like this. Heat, then the thing, then you can, the solid will be formed here. So that is the textbook example, which is also correct, no issue. So by doing so, I have my naphthalene already. Then I'm left with silver chloride, potassium chloride. Then it's up to you. You can do a few things. First, I can add water. Don't add water lah. What add water? So you always write down distilled water. You want to use deionized water? Also can. So add distilled water to the remaining solid mixture, or whatever solid mixture you call them, and stir lah, right? Next, we will filter. Residue is actually the thing that don't dissolve, right? Which is your silver chloride, solid. Your filtrate, which is the solution that goes through, is your potassium chloride solution. They're not exactly pure, right? So you need to make them pure. So what would you do next? So for the silver chloride solid, I will wash with what? Soap? No, wash with distilled water. Then after that, I will dry between tissue, your towel, your clothes, dry between pieces of filter paper. So by doing that, I get pure and dry silver chloride. What about potassium chloride? So okay, there are two variations. For this case, you can actually, only for this case, you can heat to dryness. It is rare. But then how to know what ionic salt need to dryness, which one need to crystallization? So actually, if you write crystallization, it's also correct. So actually, if I were you, I would just remember as long as it's an ionic solution, let's just crystallize it safer. So you can say that, heat until saturated, let it cool, and crystallize. then filter to obtain crystals, then lastly dry between pieces of filter paper. Oh, also, then do you remember this step? Oops. Wash crystals. Oh my god, my handwriting. With little bit of cold distilled water. Remember we did this kind of practice quite extensively. So actually this crystallization method is quite safe. So I can tell you can safely choose to use this for basically almost every ionic solution. Pretty safe. Yup. Okay, next one, oxalic acid. Oh, okay. Let's take a look. So this is what? This is an empirical formula, molecular formula question. I can tell you in O level, my empirical formula, molecular formula question is a given. They will test it for sure. Guaranteed. So you're looking at a 4 to 5 marks. Guaranteed. Money back guarantee. Okay, no, I'm just joking. So I mean I can never say anything with 100% certainty, but I'm pretty 95% certain that this comes out every O-level exam. So do take note and own this lah. It's quite easy to solve this question anyway. Alright, and then from what I've marked so far, most of you are pretty decent at this, which is a good thing. So it's 3 marks. So whenever I see this thing, empirical formula, right, I think of this table, or of course not this table lah. Like you should usually show your answer in the table. Why? Not because !aiyo! It's another thing teacher say must do, we do. Because in the table it is clearer. Meaning when the teacher mark, it is easier for them to mark you right and not penalize you. You don't want to give them any chance to nitpick on your answer, right? So do it once, do it well lah. That's the idea lah. So first one, element. So what element do we have? We have carbon, we have hydrogen, and we have oxygen. Notice something. Did I write H2? Did I write O2? No, because this is empirical. Empirical is another word for simplest. You mean H2 is the simplest form? No lah, H is the simplest form. Next, what are we given? We are given by mass. Percentage by mass. You write down percentage by mass. But actually, right, you can just treat this as mass. That is what we always do. Okay, we have 26.7%. We have 2.20%. This is 100 minus 2.2 minus 26.7. Calculator. 100 minus 2.2 minus 26.7. I'll get 71.1. Oh, cool. Do you remember the hashtag hack? So hashtag hack for mole questions. By the way, this hashtag hack works even in JC. That's proven, tested it, tried and tested. So first step, equation, which we don't do for this case because it is not a reaction So step 1 done. Second step, change to mole. And the last step, you will compare mole ratio which actually it applies here. So your change to mole is here and your mole ratio is here. Let's prove to you. So mole slash mol, so 26.7 divided by 12, 2.20 over 1 equal 2.20, 71.1 divided by 16. So this is where I use calculator. 26.7 divided by 12, I get 2.225. 71.1 divided by 16, I get 4.444. Oh, you notice I leave them with 4SF? Because they are intermediary ions. They are intermediate answers. Next one, mole ratio. So you will divide by the smallest mole. So 2.225 divided by 2.2 is pretty much equivalent to 1 lah. 2.2 divided by 2.2 is also 1. 4.444 divided by 2.2, you will get about 2. Oh, so is this the end? No, they're asking for a formula. Tell me the actual formula. So the empirical formula is actually just C1 or C H1HO2. That's it. Okay, next. Molecular mass. So it's like it's almost as if I say in the NTUC they sell one bag of 3 orange for $10. I give you $30. How many bag can I get? 3 bag lor. So it's the multiplier of 3, something like that. So in this case, the empirical formula, the simplest form, is times n equal molecular formula. This is actually just a constant. Or the maths people can think of it as, a positive integer, z plus. Okay, let's not scare you. So can you don't use n? Can you use A, B, C, D, E, F, G? Any alphabet? Why not? No issue. So the empirical formula multiplied by a few times is the real formula. MF, molecular formula, is the real formula. Which means if you compare the MR, it will also have a similar pattern. And you notice, you have the real formula, real MR90. So we know it's CH2O. So C is 12, H is 1, and O 2 bracket 16 times n. So you will get, I need to calculate. 2 times 16, 32, 44, 40. So 45 n equal to 90, which means n is... Okay, I can tell you for certainty, this integer, this n is usually a very nice number. If you calculate and you get some 3.964508, it is probably an error somewhere. It is usually a very nice number like this too. So don't stop there. That means the molecular formula is 2 times, meaning C2H4, C2H2O4. C2H2O4. Can? Yeah. Next, we're not done yet. So it says something about, we cannot eat 0. Okay, you see, whatever number they give you, got reason one. You are usually expected to use all the number given. They don't give for fun. So, one day I can only consume 0.05 gram. Okay. Then they say apparently one star fruit, a serving of star fruit has this. Okay, then let's find the mass. So what? The mole of oxalic acid, or basically C2H2O4, equal to 0.00011 mole, right? Let's find the mass then. Compare mass. 0.00011 times 90. You get 0.0099 gram. Okay, so I cannot consume more than 0.05 gram. But apparently one serving, this is actually, one serving is this much. So how many serving? Divide lor. So the maximum number of serving is 0.05 divided by 0.0099. So 0.05 divided by 0099. I get 5.051. You mean in real life I can eat 0.051 of a serving? No, right? So the maximum serving is actually just 5 serving. Because if you eat 6 serving, you exceed. 5 serving is safe. So 5 is the maximum. You can't have a 0.3 of a serving. That's just weird, right? So answer is 5. Okay, next. Alright, let's take a look. So you have apparently a lot of salts here, sure. Then which is made by precipitation. So if you, okay, I know at this point you don't memorize the periodic, the solubility table, but I will encourage you to try to memorize it, because we are like 2 weeks plus away from exam. If you remember in the WA3, you started memorizing that table very late. And what happened? Can't memorize So my recommendation, start memorizing the solubility table. I don't expect perfection. We will miss out 1 or 2 things, but at least you are starting the habit. So if you go and check, you realize that this is insoluble, soluble, 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 insoluble, soluble, insoluble, and soluble. Which means question 1 is just literally, part A is just testing your solubility table. So it's just calcium sulfate, barium sulfate, zinc carbonate. Cool. I can guarantee you again, salt prep will test in O-level. You should be expecting a range of like 3 to 5 marks, thereabout. Guaranteed. Don't believe, go and flip the past year papers and be convinced. Alright. So if you recall, salt prep, the most important question is it soluble? It is a big deal, because it will affect the method, which affect what chemical you use, which means the whole thing can be 0 mark, even if you write a long composition, you see. So you have to make calcium sulfate insoluble. You recall, insoluble only got one method, we call it precipitation. If you recall, precipitation is what? Precipitation is a very generic reaction. I just have to mix any 2 soluble substance, which give me an insoluble and soluble. So what's happening here? So I need to get CaSO4 solid. That means I must need calcium something something AQ plus something something sulfate AQ. Make sense? Because each of them contribute half, fair, right? So it seems like a very simple question, but read carefully. They say you must start from calcium carbonate. So I can tell you for sure, this is the worst question you will ever face for this salt prep. Precipitation. So I can tell you for sure, this is the worst question you will face for salt prep. I want you to prepare the salt, but I insist you must start from another one. It's the worst question. But you think of it, if you understand how to do this, then nothing can scare you anymore, right? You won't be salty. Okay, let's take a look. So you start off as calcium carbonate solid. You need to make this into a calcium something, and it's soluble. How? What reactions you learn involve a carbonate? I know, acid plus carbonate, right? Sure, then you choose an acid lor. So first step, I will add excess calcium carbonate solid to, you can always just use nitric acid or hydrochloric acid, they are quite safe. Nitric acid solution and stir lor. Cool. Next, I will filter, because I have a solution and I have some liquid and some solid mixed together. Filter to obtain the filtrate, and I will even tell them what's the filtrate. Calcium nitrate lah. Next, add equal volume, or you want to add excess also no issue of what? So you need to have a sulfate. Choose any sulfate you choose that's soluble lor. So maybe sodium sulfate solution to filtrate. So at this point, your final product appear already. Then all you need to do is again filter to obtain residue. Then go and wash and dry lah. Wash with distilled water. Dry between pieces of filter paper. Yay. Okay, question number 6. Okay, so give 3 physical property of alkaline metal. Alkaline metal, okay, be careful. Alkaline metal is not alkali. Alkaline metal are known group 1 metal are known as alkaline metal, but they are not alkali. It's just a nickname, kind of a nickname. So the properties are they are soft. What soft is what? Soft such that it can be cut with a knife. A knife. But don't worry, in exam I just look out for the word soft. But why is soft? Soft means it's soft to the extent you use knife can cut, but it's as if it's cutting butter, smooth like. Yeah, what else? It has low density. How you know? It's because it will flow on water, Remember the video? We throw the metal into the water that it sizzles on top like butter like that. Okay, what else? It also have a relatively low melting point. It is still solid. But it's a relatively low melting point compared to metals lah. Okay, question 6b, part 1. Read the question. What do they say? Using information given above. Reason. What is the information you have? Color? Who cares about color, right? Melting point of above 800. So you need to code it lah. So it is actually ionic because it has a high melting point of above 800 degrees Celsius. That's it. Okay, next. Dot and cross diagram. Okay, dot and cross diagram again. First question is what? Don't draw. First question is to figure out, is it ionic or covalent? Right? Do you recall this? So, and if it's ionic, got ions, so I must see the brackets with charges. If it's covalent, it's sharing. So it goes to extra steps, extra steps. So first one is, which one is central atom? Or another, which one in the middle lah? So this is usually the one in demand lor. What am I talking about? So let's say H2O. 2H1O, the O in the middle lah. Usually lah, usually. Second step, how many valence electron it has? Because you need to know what you have so that you know how much more you need to become a full valence electron shell. And lastly, show all valence electron. So the third step here is actually just to combat carelessness. Don't waste the 1 mark lah, right? So let's take a look. So you have it is ionic because Li nitride is actually just metal non-metal. Okay, let's check. Li is group 1. Group 1 means you have 1 valence electron. So is it easier to lose the 1 or gain 7? Lose the 1 lah. So I have Li plus. N is group 15. So you have 5 valence electron. Is it easier to lose the 5 or gain 3? So it's easier to gain 3 electron. So you get an N3 minus cross method Li3N. Okay, so let's have the brackets lah. 3 of the Li plus, and I have my N. 3 minus. So Li itself has 3 electrons, so it's 2, 1. Li plus means you lose the 1, is 2. Okay, so let's have 2 electrons here. N is 5, right? So give me the 5 first, lor. 1, 2, 3, 4, 5. Then it will be filled up with the electron from the other side. It must be full. So is this the final answer? No. Did they say show valence? Shall. No, right? So you need to draw everything. So this is actually to trap you. There are 2 more electrons you must show. So be careful if they're asking for full everything or just valence shell. I would love the valence shell question. Save time. Yep, so this is your answer. Okay, what does it mean by the word diatomic? And you notice a lot of lines and it's 2 marks here. So first and foremost, diatomic, literally di means 2 atom. So these 2 atoms are together. So I will say that, it is actually a molecule with 2 atoms. Don't write chemically bonded, because it sounds like you don't know what bond. So they are usually 2 atoms covalently bonded to each other to end up in this molecule that has 2 atoms. Yeah. Oh, next one, dot and cross. Sure. Fluorine molecule. Look at the word molecule means more than 1, right? So if you recall, this is actually F2. Okay, look, outer shell only. So F, cross, 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 dot, 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 dot. Yay! So it's a pretty standard 1 mark here lah. Alright. Okay, next. I don't believe we have this. We definitely don't learn oxidizing agent at this point. I cannot recall if we have this thing here. It's fine. We can still treat C part 1 as writing equation, so don't panic. So they say fluorine. So F2 is a gas. Huh? How do you know? Because you learn about group 17, right? You need to know the natural occurring color. So we do have to know that Cl2 is actually a greenish yellow gas. And right under it is bromine. Bromine is a reddish brown liquid, which means the melting point increase. Next one is iodine, is a purplish black or black solid. So if you check, fluorine is above. Do you think fluorine is going to be a liquid then? The trend is from the gas to the liquid to solid, right? So this is actually a gas as well. And what if they ask you astatine right below it? Should also likely be a black solid. You can't get anything blacker than solid black, right? So it's just black solid, no? So in this case, so it's F2G plus iron. Iron is a metal, solid, no? I will get what? Iron 3 fluoride. Okay, and ash. Ash means solid, right? So iron 3 fluoride means, okay, what does the 3 mean? Is it Fe3F? No. This tells me that it's Fe3 plus. F is group 17, so F minus, you cross method, FeF3. So you get FeF3 solid because it is an ash. Ash ketchum. No, kidding. Then you balance it afterwards. I like to balance at the end. If not, it's too complicated. Okay, I need 3, I need 2, I need 2. Oh, balance! Yay! Whoa, okay, this one is, we haven't learned it yet. Ammonia, no. Okay, but we will ask you how to, the equation to manufacture this Haber process. So you need to know is N2 plus H2, reversible arrow, and H3. And balance it lah, 2 and 3. Okay, next. No, it's speed of reaction. We learn it not yet. Speed of reaction. We don't learn speed of reaction. Electrolysis. Electrolysis. No go. Okay, I think you don't, even though you don't have this, but this part, this segment you can do. Why graphite can be used as an electrode? Okay, let me explain. Electrode means mass conduct electricity. So this is something we'll learn in Sec 4, don't worry, but I think we can do it like quickly. So you are supposed to explain, why graphite can conduct electricity lah? How? So I give you a little bit of time now to quickly think, and how would you get this, I guess, free mark lah? So what would you say? You'll say that in graphite, each carbon bonded to 3 other carbon, leaving one delocalized electron per carbon atom. So this, all the electron add together, all the sea of delocalized electron allow graphite to conduct electricity lah. So if you recall, to conduct electricity, you need, to conduct electricity. Conducting electricity is what? It's like, I am standing at the door of the classroom with coil. Coil is the charge, the electricity. I need to pass this charge to, who is sitting at the corner? Dwayne. And you don't throw the coil, right? So how do you get from the door, me at the door with the coil, to Dwayne with the coil, with both of us not moving? So you need someone to help us carry the charge, carry the coil. And so these things, to carry the charge, what can carry the charge? They are your delocalized electron or mobile ions, right? Yep. Either one. So where do you find delocalized electron? It is actually metal or metallic bonding, the solid and molten, and graphite. Mobile ions is ionic lah. Ionic in the AQ, molten, and also acids in the AQ form. Because remember, acid definition, acid dissociate in water to give you mobile ions, H plus ions. Paint. So this is the topic of your reactivity. So let's explain how one of these methods. So I only explain everything of course. So painted mass. This is the idea of a barrier. I need to see the word barrier. So how would you get the mark here? So I'll tell them, this egg has a barrier. I will up front give this keyword to them. Acts as barrier and prevent the iron or the steel, whatever you call it, from touching, from coming into contact or from touching lah. Oops. With water and O2. So you prevent it from coming into contact. Prevent it from coming into contact and reacting. So that's it. So you prevent what barrier prevent them from touching each other and reacting. Touch and react. You don't touch how you react, right? That's it, 2 marks. So the barrier itself is 1 mark. Next, galvanize rudder. Huh? What is galvanize? Galvanize means using zinc. Specifically a layer of zinc. So actually you compare in your series. Please stop calling me a cute zebra. Zinc is above iron leh. So we are actually putting a more reactive metal. A more reactive metal here, right? So this is actually your sacrificial protection. So actually you realize both of these are sacrificial protection. So actually they're the same explanation here. So I will tell them lah. So in this case, I will say, oh, the sacrificial metals, you don't need to give me what the metal, is a more reactive than iron. Cannot stop there, and loses its valence electron more readily. The other side would be similar, but instead of sacrificial metal, I will say zinc. Okay guys, try and squeeze. So I'll say zinc, because in this case it's zinc. Zinc is more than iron and loses its valence electron more readily. Yep, that's the first mark. And how do you get a second mark? Therefore, your sacrificial metal or zinc, depending which one you choose, will corrode, not rust, corrode in place of iron via your sacrificial protection. Alright? Okay, B, no need to do, we never learned that. Not yet at this. Oh, why do we recycle metals? Many reasons, but clear reason is because metals are finite resources, meaning it will run out. So we recycle. So this is the plus point lah, recycle lah. But there are a few problems of recycling. First and foremost, it takes time to educate people. Why? Remember your COVID, when COVID first came out, people, you need to wear masks. It took so much time to make people wear masks, and there are still people who don't bother wearing masks, right? Do you recall? So it takes time to educate people to start recycling. For example, plastic. Recycle plastic takes time, man. Now you need to pay money for plastic at NTUC, all this. It is slowly educating people lah, but it's slow. So it takes time. So even though it's slow, I still need to recycle because limited. What else? It actually will produce toxic gas. But no choice. I have limited resource. Limited metals actually. Yeah. And you know, I'm not too sure whether you're aware, but actually recycling metals can be more costly, more expensive. But people still do it. No choice. Okay, next one. Planning. So planning, you can see they actually kind of hinted you. Oh, I need okay, let me use a highlighter. I need procedure. Means you need to tell them what to do, what step variables involved. What data are you collecting? You must collect the data, right? If not, what kind of experiment are you doing? Not dataless experiment. Whoa. And when you have data, you need to also tell them how the data help you find whatever you need to find. You need to process the data lah. So these are the thing highlighted will actually mean 1 mark each if you realize. It is. So what happened here? So it says metal can react with acid. Alright. So there are many things you can do. So we can do there's many variations for real. So one example is reactivity, right? So I think generally you would think that, oh, the more reactive metal will react faster lah. I agree. I totally agree. But how are you going to quantify that? What is more reactive? What is faster? You're going to measure time. But how do you even know that you will react finish? Don't know, right? So how would we do this question? So you need to think, you need to think. So this is, I guess, your first few times doing planning, So so I think fundamentally the idea is what? The more reactive, the big idea here, the big idea, or in other words, the theory is this, the more reactive the metal means more vigorous reaction, or in other words, faster lah. So that's the idea. More reactive means faster lah, which makes sense, you see. But what are we gonna do then? What are we gonna do? Very simple. So many ways to look at it, you see. So you can look at the answer, but I'm just gonna show you one of the ways. So maybe I use limited metal. Then I record the time taken for the metal to completely disappear lah. I can see that it completely disappear means reaction finish, right? So that is one way lor. So I can wait, let me write down. So step 1, I will add excess. Okay, so planning you need to do step by step, meaning I can give your steps to someone, that someone can follow your steps and complete the reaction. So sure. So let add acid. How much acid you want? You must control it, right? Cannot be this one 10 cm and 2, right? So it depends on what you want to add. So if you say, oh, I want to add into a test tube, do you even know how much liquid can fill a test tube? A test tube can only fit 10 cm3, at most 15. So if you say add 1 liter of the acid to test tube, I mark you wrong because it's not realistic. So you need to use realistic values. So what can we do? I can actually just say use the conical flask. So maybe I can say add 200 cm3 of HCl. Okay, I would actually prefer to use nitric acid. Reasoning, because nitric acid is nitrate, right? All nitrates are soluble, so there's lesser complications. Add 200 cm3 of nitric acid solution to 3 conical flasks. 3 identical or same lah. 3 same or identical conical flasks. Yeah. So you fix the volume, roughly 200 cm3. You actually will even tell them what kind of concentration. Never mind, just write 1 mole per dm3. 1 mole per dm3 is a very standard one. 1. Then after that, you need to add your metal, right? how much metal you want to add? Do I add like 100 gram? 200 gram? No need. 5 gram? Something small, because why? The idea here is you want to use limited metal. Because you want the metal to finish, ma? When the metal finish, then you can record. So second step, I would say add maybe 5 gram lor. 5 gram of your what metal? Copper, iron, and Mg to the 3 conical flasks respectively. So each one will have one lah. Oh, okay, so once you add, the reaction start already leh. Then what are you gonna record? You're gonna record the time lah. So you can say, oh, record time taken. Time taken to do what? To go toilet. So must be very specific. Time taken for metal to dissolve or disappear completely. Because why? If you don't say completely, it's starting to disappear, can stop lah. No, you need to be consistent. This dissolve or disappear fully. Record time taken for the metal to disappear or dissolve fully. Because why? No more metal means finish react already, isn't it? Because it's acid and metal ma. No metal, no react. Finish. So once you record, so okay, I tell you what, I highlight with color. So the data is here lah. This is what you're recording, isn't it? But then how? What do you use the data to help you? So this question is what is the final thing you need to tell them? All you need to do is determine how reactive the 3 metals are to each other lah. So you think, if it's the more reactive metal, you say it's faster, right? Good. Tell them lor. The longer the time taken for metal to disappear or dissolve, the less reactive the metal. That's it. That is basically your analysis. That's it lah. 5 mark. We can do many other things lah. For example, like how much gas you can collect in a very short time frame, or maybe time taken to collect all the gas, or many ways to play around with it. So we can play around with it lah. But this is just one of the ways. I will tell you on Monday, you hand in your other paper that you don't copy answer or whatever. You can refer to textbook, no issue. You try your best. I don't need all correct. I don't even need you to worry about it. Just try. I want to know what you know, and which means I also know what you don't know lah. Then I need time to mark, right? So for Monday, Tuesday, we will likely go through planning questions. I have a stack. I compiled some questions already. It's on my desk. I'll pass it to you on Monday and teach you how to do. So it is a bit of discussion and thinking what's happening. Okay, next, calculation. So let's take a look at the calculation. Okay, you are given all this. So at the start, what happened? At the start, you have lead. So at the start, this is lead lah. Then after that, at the end, the chlorine gas go through. So this one becomes lead chlorides. I use the word chlorides because questions say chlorides of lead. I don't know what exactly it is. So be it. So what happened? So there is a difference, right? Like at the start, 415.8. After you pass through the gas, it react, now become 533.6. How come got increase? that increase is chlorine lor. So the mass of chlorine gas, mass of chlorine gas, is actually 533.6 minus 415.8. You get 117.8 gram lor. Then, I have mass, I will always change to mole lah. So mole of Cl2, 117.8 divided by 235.5. Just press calculator. 117.8 divided by 71. I get 1.659. Okay, cool. Mole. Then after that, change to volume lah. So volume of Cl2, 1.659 times 24 dm cube times 24 dm cube. Oops. 1.659 times 24 dm cube. I end up with 39.8 dm cube. Yay. That's it. Next one. Oh, another planning-ish question. Okay, don't worry. In the end of year exam, there's only going to be one planning question, which is about 5 marks lah. Yeah, cannot be so many. Don't worry, it's just one. So what is happening here? So let's take a look at what they want us to do. I need procedure. Obvious, right? You tell them, add this first, add that first, add to what, add to where, use how much. So planning question is difficult because you need to decide how much. You do a few times, you get a rough idea. So planning question is actually one of the toughest question because you need to create from nothing. Variable you need, fine. You need the data to collect. And how you're gonna use the data to help you? So question is asking about thermal stability, meaning how much stable it is to heat. So how? Do you remember just now the analogy? The more reactive the metal, the harder it is for the metal carbonate to decompose. Like what LeBron James, you can never get a basketball off him, that analogy. So tell them that is your big idea. Okay, the proper term here is called theory lah. What your theory is that the more reactive the metal, the harder it is for metal carbonate to decompose. Harder to decompose means more thermally stable lah. Yeah, the theory is fantastic. Correct. But question, what are you gonna measure? What are you gonna measure? Right? Are we gonna measure the temperature of a flame? That sounds a bit sus. Your thermometer probably can't survive that flame lah. So think, how do you measure? What do you measure? You recall, right? The reaction is the carbonate, you heat, you get the oxide and CO2, got gas. So you realize that you often target reaction with gases because it's obviously something is changed. So my idea here is I will measure the volume of CO2. So measure the volume of CO2. So there's a few ways to go about it. You can think, okay, maybe we think about in a fixed time, how much CO2 can I get? Okay, possible. Or you can say the time taken to collect all the CO2. So many variation, they're all generally okay. So Monday, Tuesday in school, we will discuss the variation. So whatever answer you have, we will talk about it and this one can, this one can, this one cannot. And I'll tell you why cannot lah. Okay, so my plan now is I will measure the volume of CO2. So first step, I will add, you need to decide how much carbonate lah. So you choose maybe 5 gram, 10 gram. So add 10 gram of each metal carbonate powder, solid, into, well, you want to use test tube, okay. You want to use boiling tube, okay. Into 3 different. Do you recall in the lab at the start of the year, you try to add powder, right? Should your test tube be dry or wet? Which one easier? Of course dry, right? 3 different dry. You want to use test tube, also can. You want to use boiling tube, also can. Boiling tube is the bigger test tube, if you recall. Okay, you add it in, then what do you do next? You will heat lah. Heat using Bunsen burner. Then using what? Your hands. Heat using Bunsen burner. Then have you measured anything? No, right? So you can tell them lah. So you will record time taken to obtain. Okay, what do you want to? So you can do anywhere else. You can either say the time taken to obtain a particular volume, or maybe record how much gas is collected in a fixed time frame. Yeah, oh, okay. So let's say okay, time taken to collect 5 cm³ of CO2 gas using a gas syringe. Okay, no, yeah, that is your rate. That is what you're gonna do. And next you need to tell me how are you gonna use this data to tell you about the stabilities. Tell them So the more reactive, rather don't use reactive, the more thermally stable the metal carbonate. Thermally stable means it doesn't break down so much. The longer time it takes to collect that 5 cm³, which means the one that takes the longest is the most stable. Yeah, that's all. Okay, next one we will go on to the titration question, right? I actually don't remember the number. Yes, I don't quite remember the number here. I think the number is something to do with 23.34 or something. Okay, yeah, I think so. You have your worksheet. Let me check the number there. Give me a moment. Yeah, EOC. By the way, the practical for us is often known as EOC because it's end of course. Because at the end of your 4 year of your secondary school life, you get to do this. Okay, I have the numbers now. So you are given 3 readings. Fine, give me the table lah. So I expect word for word, nothing missing. First, titration number. Please spell out number in exam. Initial reading, because as a student you read the thing. You read the number of the burette. Then the final reading, okay, you can switch it around if you want. Units. Then volume of what? Volume of Q. And lastly, best results. 1, 2, 3, and the numbers here are 0.00, 21.10, 22.00, 42.70, 2.10, 22.85. So the difference give you the volume that is used. 21.1. Then this one I have 20. Let me take a look. Calculator. 2.7 minus 20.70. 20.75. So if you recall, best result means plus minus 0.20. So you just have to tick, and then you get a trademark. So the trademark is what? Headings. You memorize this table word for word, 1 mark. You leave all the numbers in the table to 2SF. 2nd mark. Best results. Choose accordingly. 3rd mark. So continue. How do you find the average volume? Average volume of Q is 20.7 plus 20.75 over 2. 20.725, 20.73 cm cube, 2dp. So these are 2dp averages. Why would it be something other than 2dp? So this is the only part that's 2dp. After that is all 3SF for calculation already. So don't panic, let's use the values. So you see, using your results means this one you need to use. So if you recall, mole of Q is concentration times volume, which is 0.020 times volume, 20.73 over 1000. Zero point 0.0004146, approximate 0.000415 mole. 0.000415 mole. 3SF. Oh no, my bad. So you need to read the question properly. What are they asking for? They are asking for P. So we are not there yet, but it is a step. So you have the mole, you have a ratio. So let's do the ratio. Let's look up and see. Oh, here 1 potassium manganate react with 5 iron 2 sulfate. Sure. So mole of KMnO4, which is your potassium manganate. Don't worry about the formula. You can write potassium manganate, no issue. Okay, you know what? I'm gonna write it out, not to confuse you, okay? So mole of potassium manganate, I copying word for word, is to mole of iron 2 sulfate (1 is to 5), 0.0004146 times 5 equal to 0.002073 mole. So after that, you notice 1 dm cube. What's happening? Can we take a look and see how much P did we add? Oh, P is 25 cm cube. So 25 cm cube is 0.002073. Now they're asking for 1 dm cube. So mole of FeSO4, 0.002073 times 1000 over 25. Divide 25 times 1000. You scale it accordingly. 0.08292, which is 0.0829 mole 3SF. 0.0829 mole 3SF. Yep. Okay. So this is what's happening now. Okay, so next one. Seeing the thing here, what's happening then? Use your result in part 1. So actually, right, they are hinting to you. You just have to follow what is given to you lah, right? Then why would they actually give you that thing? Find the molecular mass. Okay, so what do we have of this FeSO4 thingy? Oh, notice here, you are given 27. So you have gram per dm cube. You have mole per dm cube. Isn't this mole in 1 mole per 1 dm cube? It is lah, it is. Oh, so it's divided by mR. So mR equal to 20, you go up. So 27.0 divided by 0.08292. You get the answer of 325.6. Actually, I'm not too sure what's the value that you have. I think your value might be different from my values. So you use your value with the same method to calculate lah, right? So average volume of Q is that. Then after you have that, you calculate. So it's 0.02 times 0.02073 4146. Then Q is potassium manganate. 1 potassium manganate is to 5. So you times 5, you have 0.202773. After that, you divide by 25 times 1000. Yeah, that's correct. Then 227 divided by this, you get 325.6. Approximate 326 3SF. 326 3SF. Then you're supposed to find X. So you see FeSO4.xH2O, the whole thing is 5.6. I don't know my XH2O. So Fe is 56 plus 32 plus 4 times 16. So this comes from here. Plus X of 2 bracket 1 plus 16 equal to 325.6. Okay, calculator, 56 plus 32 plus 64. 325.6 minus this. Oh, you end up 18x equal to 173.6. So x is 9.644, which is pretty much 10 lah. Yeah, I'm pretty sure the values you have is different from mine. I think a lot of you tried and you got an answer of 7 lah. So I think 7. I think the number here a little bit off. Let me check again. What are the numbers that 21.10, 20.7, 20. Anyway, if I'm not wrongly, the value of titration is 23.40 or something, right? But okay, whatever the case, you know the method here. Okay, next one. So you are using a 25 cm cube, but actually he blur. This student used a 20 cm cube. It means what's the immediate difference? That means the volume of pipette. What's pipette? Take a look. Pipette, is it the iron or the... pipette is the P. P is the iron sulfate. Okay lah, tell them that lah. There is the volume of your FeSO4 dot H2O is actually lower lah. Because it's not 25 cm cube, it's 20 cm cube. So if you have lesser FeSO4, the effect, it will cause your X to be higher lor. The next part of the question is, I think, the planning question already. Yeah. So you are given a magnesium powder, so MgS plus CuS. You're supposed to separate them and get only pure copper. Recall, this is acid metal reaction, right? So the big idea here is acid plus metal. If you salt plus H2, copper actually don't react with acid. So that means step 1, you can add acid, right? You want your magnesium to dissolve completely. Means you make sure you have excess acid lah. So you can say add 200 cm cube of 1 mole per dm cube of what acid? Nitric acid. Nitric acid very safe, nitric acid solution in your conical flask. After that, we will add your solid mixture in and stir until no more solid dissolves. So by doing that, your magnesium gone already. Magnesium gone. You have copper powder now. Then after you filter lah. Filter to obtain your residue, which is your copper powder. Copper solid copper. Then not clean, right? You need to wash with distilled water. And lastly, dry dry between pieces of filter paper. That's it. Alright. Any questions? You can text me